So, you've probably stared at an eye-watering API bill for your large language model and wondered why on earth you're paying for so much irrelevant context. It's honestly like leaving the air conditioning on with all the doors and windows wide open. Token bloat is just a massive issue for developers right now. We end up stuffing our prompts with huge chat histories, retrieved documents, and system instructions, and before we know it, we're hitting context limits and completely inflating our costs. But how do you actually optimize that context without losing the core meaning your LLM needs to function?
Well, welcome to this explainer. Today, we're cracking open the Headroom SDK API reference to see exactly how it solves this massive token bloat problem. Whether you're building your app in Python or TypeScript, we're going to see how this SDK acts as a highly intelligent optimization pipeline for your LLM calls.
All right, let's take a quick look at our roadmap. First, we'll meet the Headroom client. Then, we'll configure the optimization, dive into relevant scoring and transforms, look at how to simulate and measure your results, and finally, wrap up with error handling and utilities. Let's get right into it.
Starting off with Section 1, meeting the Headroom client, which is absolutely the core of your optimization pipeline.
We're starting right at the foundation, the main entry point where your messages first hit the Headroom SDK. Now, what's really brilliant here is how Headroom seamlessly adapts to your environment. If you're a TypeScript developer, you're going to use a top-level compress function to optimize your messages before sending them off to your LLM. But if you're working in Python, it beautifully intercepts your standard calls. That means you just use chat.completions.create with your usual OpenAI or Anthropic parameters and simply drop in Headroom-specific overrides like Headroom Mode or Headroom Query. It's built from the ground up for true cross-platform support.
Moving right along to Section 2, configuring your optimization by tailoring the Headroom config.
Okay, so when we open up the top-level Headroom config object, which is basically the command center for the whole pipeline, the real star of the show is the SmartCrusher. Think of the SmartCrusher like packing a suitcase with absolute ruthless efficiency. It actively chops down your token usage by analyzing your payload and just tossing out the noise based on relevance, uniqueness, and variance. Bottom line, you only end up paying for the essential context that the LLM actually needs to give a great answer.
And you get incredibly precise control over how that suitcase gets packed. Using the SmartCrusher config, you can set properties like min tokens to crush. This means the crusher literally won't even wake up unless your prompt hits a certain size. You can adjust the variance threshold and even dictate the relevance underscore tier, choosing between BM25, embedding, or hybrid. It's totally customizable to the specific vibe of your app.
Then we have the CacheAligner. If the SmartCrusher reduces the overall size, the CacheAligner config neatly folds everything. It normalizes messy white space and extracts dynamic dates. You know, those constantly changing timestamps that absolutely wreck your cache? By pulling those out, you maximize your provider cache hits, which directly saves you money and cuts down latency on the back end.
And for those really long, drawn-out chat sessions, we've got the rolling window config. This keeps your context window perfectly managed. It ensures your crucial system instructions are preserved so your bot doesn't suddenly forget its persona while gracefully dropping the oldest conversational turns first. You just define the max underscore tokens or preserve underscore recent turns, and Headroom handles the rest.
Now that our data is perfectly packed, Section 3 explores how we actually weigh its importance, relevant scoring, and transforms. Let's transition to the actual brain of the operation. This happens within the intelligent context config. Headroom doesn't just guess what's important. It uses these precise scoring weights to evaluate the exact value of every single token in your prompt. It looks at the recency of the information, the semantic similarity to the user's query, and even the token density. It's a hyper-granular way of separating the signal from the noise.
The crucial takeaway here is that you don't have to worry about the underlying math breaking when you tweak these weights. The SDK automatically normalizes all these values, like recency, semantic similarity, and token density, so they seamlessly sum to exactly 1.0. It perfectly balances itself out, saving you from some pretty complex mathematical headaches.
To calculate those weights, you use a factory function called create_score, where you can actually spin up 3 different types of relevance scores depending on what you need. First, you have the BM25 score for blazing fast zero-dependency keyword matching. Second, the embedding score for when you need deep semantic understanding. And third, the hybrid score, which beautifully combines the best of both worlds.
Next up is Section 4, simulating and measuring results so we can finally prove the ROI of your pipeline.
We've reached the end of the pipeline, where we get to ask the big question, what's in it for me? Well, one of the most valuable features is the ability to preview your optimization without actually making a costly LLM API call. In TypeScript, this returns a compressed result, showing your tokens saved. In Python, you just use the dedicated chat.completions.simulate function to get back a simulation result.
Look at how clearly this simulation results maps out your immediate ROI. You can see exactly how many tokens went in as tokens underscore before, how many came out as tokens underscore after, and your ultimate savings underscore %. It even lists the exact transforms that were fired off during the pipeline. And if we dig into the waste signals object nested inside that Python simulation result, we see the exact types of luggage the SmartCrusher left behind. It breaks down the waste into specific counts. How many tokens were just JSON bloat? How much was HTML noise? How much was useless whitespace or dynamic date tokens busting your cache? It brings total transparency to your data structures.
Now, when you transition from simulating to making live calls, the request metrics object captures your ultimate developer bottom line. It directly compares your costs before and after optimization. So it's no longer just about tokens. It's about the actual dollars and cents you saved on every single request, alongside your input and output token metrics.
Finally, let's explore Section 5, Error Handling and Utilities, so you know how to troubleshoot the pipeline. We've pulled this ready-made cheat sheet of error classes straight from the API reference. Having clear guardrails is essential. With these cleanly defined exception classes, which all inherit from the base Headroom error, you can quickly identify exactly what went wrong. Whether it's a simple configuration error from a bad setting, a Headroom auth error giving you a 401, or a deeper tokenization error where the token counting just failed, you know exactly where to look.
And if you happen to be interacting directly with the Headroom proxy server, there is a highly useful function called map_proxy_error. You simply pass it the status, type, and message, and it seamlessly converts those raw proxy error responses into the manageable, strongly typed exception classes we just looked at. It keeps your error handling incredibly clean. To round out your developer toolkit, Headroom provides a robust suite of observability utilities. You can run getStats for quick session data, use getMetrics to query your stored database metrics, or call getSummary to look at aggregate stats across the board. You can even use GenerateReport to export beautiful HTML reports to show off your overall pipeline performance and all those cost savings to your boss.
We've absolutely covered a lot of ground today, from clients and configs to deep semantic scoring and actionable metrics. But I want to leave you with this powerful question to think about. If you could use Headroom's simulation tools right now to preview your token savings before spending a single dime on an API call, what part of your LLM pipeline would you optimize first? Seriously, dive into the docs, run a simulation, and find out exactly how much baggage you can leave behind. Thanks for hanging out with me on this explainer, and happy coding!